Question number 1A. Kisiki and Jembe are riding on a circular path. Kisiki completes a round in 24 minutes, whereas Jembe completes a round in 36 minutes. If they both started at the same place and time and go in the same direction, after how many minutes will they meet again at the starting point? Okay, so to solve this problem, we are going to use the LCM concept. So first, let us list the numbers which we have given, of which we are going to find their lowest common multiple. Okay, so we sketch a table, and then we are going to have here 24 and here 36. So we ask ourselves what is the lowest number which can divide either of these two numbers. Okay, so the lowest number is 2. So we write 2 here, and then we say 24 divided by 2, here is 12, and 36 divided by 2 is 18. Okay, also for here, the next number is still 2, so we are having 2 here. The value here is 6, and here is 9. Okay, we can still use number 2 here, so the value here is going to be 3, and here the value is still 9. Our next number is 3, so dividing 3 by 3 is 1, and here is 3. And our next number is 3, so here we have 1, and here we have 1. Now, to find the LCM, we are going to take 2 times 2 times 2 times 3 times 3, of which after solving these values we are going to have 72. So we say that they will meet again after 72 minutes. Part B of the question: an empty bottle weighs 115 grams. If 45 tablets, each weighing 3/5 grams, are put in a bottle, what is the total weight? Okay, so first we are going to find the weight of tablets. So we are going to take 3/5 grams times 45 tablets, which is the total number of tablets. Solving these values, we are going to have 27 grams. So to find the total weight, we are going to take weight of the empty bottle plus weight of tablets. The values are 115 grams plus 27 grams, of which after solving the values, we are going to have 142 grams, and this is the answer. Question number 2, part A, Roman 1, express those expressions in the form of A plus B under root 3. This is the radical and exponential problem. So we have in brackets under root 3 plus 5 squared. Let us now expand this expression. We are going to have in brackets under root 3 plus 5 times in brackets under root 3 plus 5. Now let us open the brackets. Our expression is going to be under root 3 times under root 3 plus 5 times under root 3 plus 5 times under root 3 plus 5 times 5. Simplifying this, we are going to have 3 plus 10 under root 3 plus 25. Okay, so next let us combine the like terms. We are going to have 28 plus 10 times under root 3. And this is going to be our answer. Roman 2, express that expression in the form of p plus q times under root 3, where p and q are rational numbers. Okay, so first, from the expression given, let us expand the numerator. So our expression is going to be, in brackets, under root 3 plus 5 times, in brackets, under root 3 plus 5 over, in brackets, 7 times under root 3 plus 2. Next, let us open the brackets for the numerator. Our equation is going to be 3 plus 5 times under root 3 plus 5 times under root 3 plus 25 over, in brackets, 7 times under root 3 plus 2. Solving further this expression, we are going to have 10 times under root 3 plus 28 over, in brackets, 7 times under root 3 plus 2. Okay, so next we are going to rationalize the denominator by multiplying both numerator and denominator by the denominator value, but we are going to change the sign. So our expression is going to be, in brackets, 10 times under root 3 plus 28 times, in brackets, 7 times under root 3 minus 2 over, in brackets, 7 times under root 3 plus 2 times, in brackets, 7 times under root 3 minus 2. Simplifying this further, we are going to have 210 minus 28 times under root 3 plus 196 times under root 3 minus 56 over, in brackets, 7 times under root 3 squared minus 2 squared. Keep simplifying. Our expression is going to be 154 plus 176 times under root 3 over 49 times 3 minus 4. Solving for the denominator, our expression is going to be 154 plus 176 times under root 3 over 143, of which this expression can also be written as 154 over 143 plus 176 times under root 3 over 143, and this is our answer. Part B of the question, we are supposed to solve for x after being given that expression. Okay, so this is the exponential problem. In order to solve for x, we are going to express each term as a power to base. So our expression is going to be 3 power 24x times 3 power 4 equals to 3 power 1. For our left hand side, we are going to add the exponents because their bases are the same. Our expression is going to be 3 power 24x plus 4 equals to 3 power 1. Now we are going to compare the exponents from both sides because their bases are the same. So our expression is going to be 24x plus 4 equals to 1. Okay, let us now collect the like terms. We are going to have 24x equals to 1 minus 4. This is also going to be 24x equals to negative 3. Okay, so now let us make x as a subject. We are going to have x equals to negative 3 over 24, of which after solving the values we are going to have x equals to negative 1 over 8. And this is our answer. Question number 3a. The Venn diagram below shows the number of elements in set P and Q. If number of P union Q equals to 95, we are supposed for Roman 1 to calculate the value of x. Okay, so for this one, we know that the sum of all numbers in the set given equals to the number of P union Q. We can write this as 38 plus 2x plus x plus 13 plus x equals to number of P union Q. But we have been given that number of P union Q equals to 95. So our equation is going to be 38 plus 2x plus x plus 13 plus x equals to 95. Let us now combine the like terms. Our equation is going to be 4x equals to 44. Divide by 4 both sides. Our equation is going to be x equals to 11. And this is the value of x required. For Roman 2, we are supposed to calculate the number of P intersection Q complement. From the given sketch above, the number of P intersection Q equals to 38 plus 2x plus 13 plus x. Okay, let us combine the like terms. The number of P intersection Q is going to be 3x plus 51. But from Roman 1 above, the value of x equals to 11. So let us substitute x with 11. Our equation is going to be 3 times 11 plus 51, of which after solving these values we are going to have 84. Therefore, the number of P intersection Q complement equals to 84. Part B of the question, the age of Timothy is 1 over 8, the age of his father. If the sum of their ages is 54 years, find the age of the father. Okay, so for this one, let x be the age of the father. Then the age of Timothy is 1 over 8x. The sum of their age is 54. We can write this as x plus 1 over 8x equals to 54. For now, let us combine the like terms from our left-hand side. Our equation is going to be 9 over 8x equals to 54. Let us now make x as a subject. Our equation is going to be x equals to 54 times 8 over 9, of which after solving the values we are going to have 48. Therefore, the age of a father is 48 years. Question number 4, part A. Find the equation of a line passing through 6, 4 and perpendicular to the line whose equation is 12x plus 6y equals to 9. Okay, so this is the coordinate geometry problem. To solve the problem, we need first to find the slope of the equation given. So let us express the equation in a form of y equals to mx plus c, where m is the slope. So our equation is going to be y equals to negative 2x plus 3 over 2. So from this one, the slope, we are going to call it m1 equals to negative 2. But the line passing through 6, 4 is perpendicular line to the given line. Then the product of their slopes produce negative 1. That is m1 times m2 equals to negative 1. But we have the value for m1. Let us substitute it with negative 2. So our equation is going to be negative 2 m2 equals to negative 1. Next, let us divide by negative 2 both sides. So our equation is going to be m2 equals to 1 over 2. Now we have the slope for m2, which equals to 1 over 2, and the point is 6, 4. We can now find the equation of the line. Okay, so from this relation, which says y equals to m in brackets x minus x1 plus y1, let us substitute the value of m and x1, which equals to 6, and y1, which equals to 4. Then our equation is going to be y equals to 1 over 2 times in brackets x minus 6 plus 4. Now let us open the brackets. Our equation is going to be y equals to 1 over 2x minus 3 plus 4. Let us now combine the constant terms. Our equation is going to be y equals to 1 over 2x plus 1. We can rewrite this equation as 2y minus x equals to 2. And this is the required equation. Part B, if A equals to 2i plus 3j, B equals to 19i minus 15j, and C equals to 5i minus 7j, find the value of x such that xa plus yc equals to b. Okay, so this is the vector problem. So first step, let us substitute the values for a, b, and c into our expression. So our expression is going to be x times in brackets 2i plus 3j plus y times in brackets 5i minus 7j equals to 19i minus 15j. Next, let us open the brackets. Our equation is going to be 2xi plus 3xj plus 5yi minus 7yj equals to 19i minus 15j. Okay, so next let us combine the like terms. For the left hand side, our equation is going to be in brackets 2x plus 5y I plus in brackets 3x minus 7y j equals to 19i minus 15j. Now let us compare the terms from both sides. We are going to have 2x plus 5y equals to 19. We are going to call this as equation number 1. And also we are going to have 3x minus 7y equals to negative 15. And we are going to call this as equation number 2. Okay, now we have a set of two simultaneous equations of which we are going to solve them by substitution method. So from equation number 1, let us make y as a subject. Our equation is going to be y equals to 19 minus 2x over 5. We are going to call this as equation number 3. Let us now substitute equation number 3 into equation number 2. Our equation is going to be 3x minus 7 times in brackets 19 minus 2x over 5 equals to negative 15. Let us now open the brackets. Our equation is going to be 3x minus 133 plus 14x over 5 equals to negative 15. Okay, so let us now multiply by 5 for each term. Our equation is going to be 15x minus 133 plus 14x equals to negative 75. Next, let us combine the like terms. Our equation is going to be 15x plus 14x equals to negative 75 plus 133. Solving this, we are going to have 29x equals to 58. Let us now divide by 29 both sides. Our equation is going to be x equals to 2, and this is the required value of x. Question number 5, part A. Given that xy equals to 2 centimeters, BC equals to 3 centimeters, and area of XYCB equals to 10 centimeters squared, calculate the area of triangle AXY. Okay, so this is the similarity problem. To solve the problem, we need first to check if the triangle AXY and the triangle ABC are similar. Let us check that. So angle AXY equals to angle ABC because they are corresponding angles. Angle AYX equals to angle ACB. Also, the reason being they are corresponding angles. Angle BAC is common for both triangles. Then we can say that triangle AXY is similar to triangle ABC by AAA theorem. Now, since the triangle AXY and the ABC are similar, then corresponding sides are proportional, meaning they give the constant ratio. Also, the square of this ratio gives the ratio of the area of the triangles. We have been given that xy equals to 2 centimeters and BC equals to 3 centimeters. The ratio is xy over BC, which equals to 2 over 3. The square of the ratio of triangles equals to area of a triangle AXY over area of a triangle ABC, which equals to 2 over 3 squared, of which expanding this we are going to have 4 over 9. So let area of a triangle AXY equals to A, then area of a triangle ABC equals to area of a triangle AXY plus area of a triangle XYCB, which equals to A plus 10. Then A over A plus 10 equals to 4 over 9. Let us now cross multiplication this equation. We are going to have 9A equals to 4 times in brackets A plus 10. Let us now open the brackets. Our equation is going to be 9A equals to 4A plus 40. Let us now combine the like terms. Our equation is going to be 5A equals to 40. Let us now divide by 5 both sides. Our equation is going to be A equals to 8. Therefore, area of a triangle AXY is 8 centimeters squared. For part B, determine the length of one side of a regular quadrilateral inscribed in a cycle of a radius 10 centimeter. Okay, so for this one, for the regular quadrilateral inscribed in a cycle, the length of one side can be given as L equals to R times under root 2, where R equals to the radius of a cycle. Now we have been given the value of R equals to 10 centimeters. Let us now substitute this value into our equation. So our equation is going to be L equals to 10 times under root 2. So the length of one side equals to 10 under root 2 centimeters. Question number 6a. Juma sells 1 liter of milk at 600. How many liters of milk will Juma sell to get 208,800? Okay, so first let the number of liters required equals to x. Then we can write the given information as 600x equals to 208,800. Okay, now let us divide by 600 both sides. We are going to have x equals to 348. Therefore, 348 liters are required. Part B, the compression I of a spring is directly proportional to the thrust T newtons exerted on it. If a thrust of 2 newtons produces a compression of 0.4 centimeter, for Roman 1, we are supposed to find the compression when the thrust is 5 newtons. So this is the variation problem. We have been told that compression I is directly proportional to the thrust T. Mathematically, you can write that I is directly proportional to T. Now let us introduce the constant of proportionality K. So our equation is going to be I equals to KT. Let us now make K as a subject. Our equation is going to be K equals to I over T. Let us now substitute I with 0.4 centimeter and T with 2. Our equation is going to be K equals to 0.4 over 2, of which after solving this we are going to have 0.2. Now from our formula for K above, which says K equals to I over T, let us now substitute the value for K equals to 0.2 and T equals to 5 in order to find the value of I. So our equation is going to be 0.2 equals to I over 5. Now let us multiply by 5 both sides. Our equation is going to be I equals to 0.2 times 5, of which after solving this we get 1. So the value is going to be 1 centimeter. For Roman 2, we are supposed to find the thrust when the compression is 0.7 centimeters. For this one as well, we are going to use the same formula for K as shown above, which says K equals to I over T. So now let us substitute the values for K equals to 0.2, I equals to 0.7 centimeter in order to find the value of T. So our equation is going to be 0.2 equals to 0.7 over t. Making t as a subject, our equation is going to be t equals to 0.7 over 0.2, of which after solving the values we are going to have 3.5. Therefore, the answer is 3.5 Newton. Question number 7a. Kieku has to share 80 books with his younger sisters Upendo and Okuli. He decided that for every 2 books that Okuli gets, Upendo gets 3 and he gets 5 books. Find the number of books each gets. Okay, so this is the ratio problem. Let us express the shared books in terms of ratio. So we are going to have 2:3:5. Let us take the sum of the ratio. We are going to have 2 plus 3 plus 5, which after summing this we are getting 10. Then for Okuli, we'll get 2 over 10 times 80 books, of which after solving this we get 16 books. Upendo will get 3 over 10 times 80 books, of which after solving this we get 24 books. Kieku will get 5 over 10 times 80, which after solving this we get 40 books. Therefore, those are the number of books each one will get. Part B, Nyaumwa invested a certain amount of money in a bank which pays interest rate of 6% after every 6 months. After 5 years, his total savings were 9.6 million. Determine the amount of money Nyaumwa invested initially. So this is the simple interest problem. So let us consider the following formula, which says A equals to P times, in brackets, 1 plus RT over N, whereby A is the total saving for time T, which equals to 9.6 million. P equals to the amount invested initially. R equals to the rate, which equals to 6%. And N is the number of interest per year, which equals to 2. And T is the total number of years the money were invested, which equals to 5. Okay, so now let us substitute these values into our formula. We are going to have 9.6 million equals to P times, in brackets, 1 plus 6 times 5 over 100 times 2. Let us now compute the inside the bracket. Our value is going to be 9.6 million equals to 1.15 P. Let us now divide by 1.15 both sides. Our equation is going to be P equals to 9.6 million over 1.15, of which after solving these values we are going to have P equals to 8,347,826.09, and this is the amount which was invested initially. Moving on to question number 8, part A. The 20th term of an arithmetic progression is 60 and the 16th term is 20. Find the sum of the 40 terms. So we have been given the 20th term, which is A20, equals to 60. From the general formula for any term in arithmetic progression, which says AN equals to A1 plus, in brackets, N minus 1 D. Let us now substitute N with 20 and AN with 60. Our equation is going to be 60 equals to A1 plus, in brackets, 20 minus 1D. Okay, simplifying this, we are going to have A1 plus 19D equals to 60. Let us call this as equation number 1. Also, we have been given that 16th term equals to 20. Using the same formula as above, let us now substitute N with 16 and AN with 20. Our equation is going to be 20 equals to A1 plus, in brackets, 16 minus 1 times D. Then we can solve this as A1 plus 15D equals to 20. We are going to call this as equation number 2. Let us now solve the simultaneous equation by substitution method. So we are going to make A1 as a subject from the equation number 1. So our equation is going to be A1 equals to 60 minus 19D, and we are going to call this as equation number 3. Let us now substitute equation number 3 into equation number 2. Our equation is going to be 60 minus 19D plus 15D equals to 20. Let us now combine the like terms. Our equation is going to be negative 4D equals to negative 40. Now let us divide by negative 4 both sides. We are going to have D equals to 10. Now we have the value for D. Let us now substitute this value into our equation number 3. So our equation is going to be A1 equals to 60 minus 19 times 10. Of which, after solving this, we are going to have A1 equals to negative 130. Now, to find the sum of 40 terms, let us consider the following formula, which says Sn equals to n over 2 times, in brackets, 2A1 plus, in brackets, n minus 1 times D. So let us substitute n with 40, A1 with negative 130, D with 10. Our equation is going to be Sn equals to 40 over 2 times 2 times negative 130 plus, in brackets, 40 minus 1 times 10. Solving this, we are going to have Sn equals to 2600, and this is our answer. Part B, a shopkeeper invested 4.8 million for 5 years. If the amount of money accumulated is 7.730,450, calculate the compound interest rate. For the compound interest rate, let us consider the following formula, which says A equals to P times, in brackets, 1 plus R power n, whereby A is amount accumulated, which equals to 7.7 million. P is amount invested, which equals to 4.8 million. R is a compound interest rate, and N is a number of years, which in our question is equal to 5 years. So let us now substitute these values into our formula. Our equation is going to be 7,730,450 equals to 4.8 million times 1 plus R power 5. Okay, so let us now divide by 4.8 million both sides. Our equation is going to be 1.61 equals to, in brackets, 1 plus R power 5. Let us now apply the natural log in both sides. Our equation is going to be ln 1.61 equals to ln, in brackets, 1 plus R power 5. Let us now apply the exponential rule for our right hand side. Our equation is going to be ln 1.61 equals to 5 ln, in brackets, 1 plus R. Next, let us divide by 5 both sides. Our equation is going to be ln 1 plus R equals to ln 1.61 over 5. So reading ln 1.61 from the table, we are going to have ln 1 plus R equals to 0.4766 over 5. Solving this, we are going to have ln 1 plus R equals to 0.0953. Reading the inverse of ln 0.02968 in a table, our equation is going to be 1 plus R equals to 1.1. Now from here, solving for R, we get R equals to 0.1. We can further express R as a percentage by taking this value times 100. We are going to have R equals to 10%. And this is the rate required. Question number 9, part A. Find the length marked y in 4 significant figures. Okay, so this is the trigonometric problem. To find y, let us find the length BD first from the triangle BDC. Okay, so let us recall the tangent formula, which says tan theta equals to opposite side BD over adjacent side DC. Okay, so from our figure, we see that DC equals to 20 centimeter and theta equals to 30 degrees. So let us substitute these values into our formula. So we are going to have tan 30 degrees equals to BD over 20. Let us now make BD as a subject. Our equation is going to be BD equals to 20 times tan 30 degrees. Now, reading tan 30 degrees from the table, our equation is going to be BD equals to 20 times 0.5774, of which after solving this, we are going to have 11.548. Okay, so now we have the value for BD. Then let us apply the sine formula for a triangle ABD, which says sine theta equals to opposite AB over hypotenuse BD. Okay, so let us substitute the value for theta as 45 degrees, BD as 11.548, and AB as y. Our equation is going to be sine 45 degrees equals to y over 11.548. Now let us make y as a subject. Our equation is going to be y equals to 11.548 times sine 45 degrees. Now, reading sine 45 degrees from the table, our equation is going to be y equals to 11.548 times 0.7071. Solving this, we are going to have y equals to 8.1655908. We have been told to write our answer in 4 significant figures. Then we are going to have y equals to 8.166 centimeters. And this is our answer. Part B, a 4 meters ladder rests against a vertical wall with its foot 2 meters from the wall. How far up the wall does the ladder reach? Give your answer into 2 decimal places. Okay, so let us consider the following sketch for this problem. So here we have a wall, and here we have a ladder, and we can name our points. Here is A, B, C, and here is 4 meters, and here is 2 meters. To find how far the wall reaches with the length AB, we are going to consider the Pythagoras theorem, which says AC squared equals to AB squared plus BC squared. So from our sketch, AC equals to 4 meters and BC equals to 2 meters. So let us substitute these values into our formula. So our equation is going to be 4 squared equals to AB squared plus 2 squared. Okay, let us make AB squared as a subject, and expanding these values, we are going to have AB squared equals to 16 minus 4, of which after solving these values, we are going to have 12. So AB squared equals to 12. Now let us square both sides. We are going to have AB equals to 2 under root 3. Okay, so reading under root 3 from the table, our equation is going to be AB equals to 2 times 1.732, of which solving this we are going to have AB equals to 3.464. So the length required is going to be 3.46 meters. Question number 10, part A. Use the quadratic formula to solve x squared plus 4x minus 12 equals to 0. So let us recall the general formula from quadratic, which says x equals to negative b plus or minus under root b squared minus 4ac over 2a. From our equation above, a equals to 1, b equals to 4, and c equals to negative 12. Let us now substitute these values into our equation. Our equation is going to be x equals to -4 plus or minus under root 4 squared minus, in brackets, 4 times 1 times -12 over 2 times 1. Computing this, we are going to have x equals to -4 plus or minus 8 over 2. So from here we say x equals to -4 plus 8 over 2, which equals to 2, or x equals to -4 minus 8 over 2, which equals to -6. So the values for x are 2 or -6. Part B, a garden measuring 12 by 16 meters is to have a penetration pathway of equal width constructed all around it, increasing the total area to 285 square meters. What will be the width of the pathway? So let us consider the sketch for this problem. So first we sketch a garden with measurement of 12 by 16 meters, and then we sketch a pathway which is constructed around it. So we are going to label the width of a pathway by x because we don't know the value. The distance here is going to be 12 plus 2x, and here is going to be 16 plus 2x. Okay, so from the sketch, x is the width of a pathway. Okay, so the area of a garden is given by total length times total width. We have the values from the sketch above. Let us replace them in our formula. Our equation is going to be area of a garden equals to, in brackets, 12 plus 2x times, in brackets, 16 plus 2x. Let us now expand this expression. Our equation is going to be area of a garden equals to 192 plus 24x plus 32x plus 4x squared. But we have been given the area of a garden, which equals to 285 meters. So let us substitute this value into our equation. Our equation is going to be 285 equals to 192 plus 56x plus 4x squared. Let us now express this equation in a quadratic format. Our equation is going to be 4x squared plus 56x minus 93 equals to 0. Okay, so let us recall the quadratic equation formula, which says x equals to -b plus or minus under root b squared minus 4ac over 2a. Now from our equation above, a equals to 4, b equals to 56, and c equals to -93. Now let us substitute these values into our equation. Our equation is going to be x equals to -56 plus or minus under root 56 squared minus, in brackets, 4 times 4 times -93 over 2 times 4. Computing this, we are going to have x equals to negative 56 plus or minus 68 over 8. We are only going to take the positive sign because the length cannot be negative. So we are going to have x equals to negative 56 plus 68 over 8, of which after solving these values we are going to have x equals to 1.5 meters. And this is our answer. Question number 11. A farmer has 20 hectares for growing tomatoes and cabbages. The cost per hectare for tomatoes is 48,000 and for cabbages is 32,000. The farmer has budgeted shillings 768,000. Tomatoes require 1 man days per hectare and cabbages require 2 man days per hectare. There are 36 man days available. The profit on tomatoes is shillings 160,000 per hectare and on cabbages is 192,000 per hectare. Find the number of hectares of each crop the farmer should plant to maximize the profit. Okay, so this is the linear programming problem and we need to solve it graphically. Okay, so we are going to follow the following steps in order to solve this problem. So the first step, we are going to form the inequalities. So we are going to let x equals to number of hectares for tomatoes and y equals to number of hectares for cabbages. A farmer has 20 hectares. Sum of hectares for tomatoes and cabbages should not exceed the available hectares. So our inequality is going to be x plus y is less or equal to 20. Also, we have been told that the cost per hectare of tomatoes is 48,000. The cost for x hectares will be 48,000 x. And the cost per hectare of cabbages is 32,000, meaning the cost for y hectares will be 32,000 y. And the total should be equal or less than the available budget. So our inequality is going to be 48,000 x plus 32,000 y is less or equal to 768,000. Also, we have been told that tomatoes require 1 man days per hectare. Man days for x hectares will be x. And cabbages require 2 man days per hectare. Then man days for y hectares will be 2y. The total number of man days should be equal or less than the available man days. So our inequality is going to be x plus 2y is less or equal to 36. Also, let us list the non-negative inequalities, which we have x is greater or equal to 0 and y is greater or equal to 0. So now we have our inequalities. Let us form the boundary lines from inequalities in order to draw the graph. So our first boundary line will be x plus y equals to 20. The second boundary line will be x plus 2y equals to 36. Also, we are going to have 48,000 x plus 32,000 y equals to 768,000, which we can simplify this to be 3x plus 2y equals to 48. And this is going to be our third boundary line. Other boundary lines which we have are x equals to 0 and y equals to 0. Okay, now before drawing the graph, let us identify the objective of a farmer. The profit on tomatoes is 160,000 per hectare, and for x hectares the profit is going to be 160,000 x. And the profit on cabbages is 192,000 per hectare. Then for y hectares the profit is going to be 192,000 y. The total profit will be 160,000 x plus 192 y. Then the objective function is to find the best solution for x and y that is going to maximize the profit. So our objective function is going to be function of x and y max equals to 160,000 x plus 192,000 y. So next we are going to draw the graph. Let us consider the intercept method to find the sample points on the lines. Okay, so for x plus y equals to 20, when x equals to 0, y is going to be 20, and the points are going to be 0, 20. And when y equals to 0, x is going to be 20, and the point is 20, 0. Okay, for x plus 2y equals to 36, when x equals to 0, y is going to be 18, and the point is 0, 18. And when y equals to 0, x is going to be 36, and the point is 36, 0. For 3x plus 2y equals to 48, when x equals to 0, y is going to be 24. The point is 0, 24. And when y equals to 0, x is going to be 16. And the point is 16, 0. So drawing the graph now, we start by drawing x and y axis, and we are going to shade the negative regions. Next, we are going to draw the boundary lines one after another by connecting the sample points we have, and we are going to shade the unrequired regions. Then we identify the feasible region and label it. Our final graph is going to be like this. Now, from the graph, we have the feasible region containing corner points and the possible solution. Let us now summarize the corner points and the results from the objective function. Okay, so we are going to sketch our table, and here we are going to have the corner points, and here we are going to have the objective function, which equals to 160,000 x plus 192,000 y. So let us list the corner points which we have. So we have point O with 0, 0, point A 0, 18, point B 4, 16, point C 8, 12, and point D 16, 0. And the value for the objective function for the first point is going to be 0. The second one is 3,456,000. The next is 3,712,000. Next is 3,584,000. Next is 2,560,000. From the table above, we can see that point B, which have 4, 16, gives the maximum value of a function. Therefore, the farmer should plant 4 hectares of tomatoes and 16 hectares of cabbage in order to get the maximum profit. Question number 12. The heights of some plants grown in a laboratory were recorded after 5 weeks. The result is shown in the table below. So we are going to start with part A, which we are supposed to calculate the mean and the mode. To calculate the mean, we are going to add 2 columns for class mark and for the fx. Okay, so we know that class mark is obtained by taking the average of the class boundaries. For example, in the first class, we are going to take 11 plus 15 divided by 2, which after solving that we get 13. So let us fill the remaining parts, which the next class is going to be 18, the next one is 23, the next one is 28, the next one is 33, and the last one is 38. And also for the column of fx, we are going to take the value of f multiply by the value of a class mark. So for example, for the first one, we are going to take 13 times 4, which equals to 52. So we are going to use the same approach for the remaining figures. So the next one is going to be 144. Next is 460. Next is 588. The next one is 396. And the last one is 114. So now let us find the sum of the frequency, which equals to 68, and the summation of fx, which after summing these values we are having 1754. Okay, now to calculate the mean, let us recall this formula, which says x equals to summation of fx over summation of f. Now let us substitute the values which we have in our table for fx and f. We are going to have x equals to 1754 over 68, which after solving this we are going to have 25.79. Then this is going to be our mean. And for the mode, let us consider the following formula, which says mode equals to L plus, in brackets, D1 over D1 plus D2 times C, whereby L is a lower real limit for the model class, D1 is the difference between the frequency of a model class and that below, and D2 is the frequency between the frequency of a model class and that above, and C is a class size. And something to remember is the model class is the class that has the largest frequency. So from our table, the model class is 26 to 30. Then our L is going to be 26 minus 0.5, of which after solving this, we are going to have 25.5. D1 is going to be 21 minus 20, which equals to 1. D2 is going to be 21 minus 12, which equals to 9. And C equals to 5. Let us now substitute these values into our formula. So we are going to have mod equals to 25.5 plus 1 over 1 plus 9 times 5, which after solving this we are going to have 26, and this is the value of a mode. Part B, we are supposed to draw a cumulative frequency curve from the data given. So to draw that, we are going to add the column for cumulative frequency and the upper real limit. So our upper real limit is going to be, the first one is 15.5, the next is 20.5, next is 25.5, next is 30.5, next is 35.5, and the last one is 40.5. And for the cumulative frequency column, for the first one, we are having 4. The next one is 4 plus 8, which equals to 12. The next one is 32. Next is 53. Next is 65. And the last one is 68. So we are going to draw the cumulative frequency curve using cumulative frequency against the upper real limit. We are going to start by drawing axis, and we are going to label as cumulative frequency and the upper real limit. And then we are going to mark the points, and we are going to join the points using a free hand and not a ruler. Our final graph is going to be like this. Part C, we are supposed to estimate the median from the graph. So to estimate the median, we are going to take the total frequency divided by 2. Then we read the corresponding upper real limit of this value from the graph. And this will be the approximated median. So we are having summation of f divided by 2, which equals to 68 divided by 2, of which after solving this we are having 34. Now from our graph, we are going to have the approximated median at this point. Now from here, we can say that the approximated median equals to 26.4. Question number 13, part A. Prove that the sizes of the angles in the same segment of a cycle are equal. Okay, so this is the cycle problem. Let us now sketch the problem. So we are going to sketch our cycle, and then we are going to draw the shapes inside. We have point A, B, C, D, and here is the center, which is O. Okay, so from the figure, we need to prove that angle ACB equals to angle ADB. O is a center, and we have segment AB. We know that angle formed at the center is twice the angle formed at the circumference for the same segment. Then we say that angle AOB equals to 2ACB. Also, angle AOB equals to 2ADB. From these two facts, we see that 2ACB equals to 2ADB. For this one, let us divide by 2 both sides. We are going to have ACB equals to ADB. And this proves that the sizes of angles in the same segment of a cycle are equal. Part B, in the figure below, O is a center of a cycle and AD bisects angle BAC. We are supposed to find angle BCD. From the figure, angle BAC equals to 90 degrees. The reason being, angle at the circumference is half the angle at the center. Also, angle BAD equals to 45 degrees. Reason being, line AD is a bisector of angle BAC. But angle BAD equals to angle BCD because they are angles at the same segment. Therefore, angle BCD equals to 45 degrees. Part C, Kicheko and Mtakuja are two villages on latitude 60 degrees south. The distance between Kicheko and Mtakuja measured along the parallel of latitude is 1,111 kilometers. Find the difference between their longitude in two significant figures. This is the Earth as a sphere problem. Since the two places are located on a different longitude but the same latitude, then we are going to use the following formula for the distance, which says distance equals to 2 times pi times r times phi times cos theta over 360, whereby r equals to Earth's radius, which we know is 6,370 kilometers. Phi is a difference in longitude. Theta is a latitude, which equals to 60 degrees. And the given distance is 1,111 kilometers. Okay, so now let us substitute the values into our formula. So our equation is going to be 1,111 equals to 2 times 3.14 times 6,370 times phi times cos 60 degrees over 360. Okay, so now let us make phi as a subject. We are going to have phi equals to 1,111 times 360 over 2 times 3.14 times 6,370 times cos 60 degrees. So solving these values, we are going to have phi equals to 19.996, of which this one can be approximated as 20 degrees. Therefore, the difference in longitude is 20 degrees. Question number 14. Mr. Kijembe started a business on 16th March 2011 with a capital in cash 2,066,000. So we have been given several transactions there. We are supposed to record the above transactions in a cash account ledger, and we are supposed to extract a trial balance. And also we are supposed to state two uses of the trial balance. Okay, so this is the accounting problem. So we are going to start by the cash account. So we are going to sketch our cash account. Is going to have two sides, debit side and the credit side. The cash account is going to have 4 columns on our debit side and also 4 columns for our credit side. We are going to label the columns as date, particular, folio, amount. And also on the credit side we have date, particular, folio, amount. So now let us finalize our cash account by listing the transactions which have been incurred. So we start with the cash capital, 2,066,000. Next is cash purchases of goods, 1 million. And then purchases of shares for cash, 1.1 million. And then made some cash sales, 900,000. Made some purchases by cash, 800,000. Made some cash sales, 1.4 million. And then paid some rent, 300,000. Next, let us make summation for the amount on a debit side. So the total here is going to be 4,366,000. So we are going to take the same figure here on a credit side as 4,366,000. Next, let us find the balancing figure here. So our balance carried down is going to be 1,166,000, and this is going to be the same figure as balance brought down, the same figure, 1,166,000, and this is our cash book. And next we are going to prepare the trial balance. So we are going to sketch our trial balance. The trial balance is going to have 4 columns. So the first one is for account description. The second one is for folio. The next is debit, and the next one is credit. So first we start with the cash balance, which from our cash book is going to be 1,166,000. And also we have capital on credit side, which is 2,066,000. And also we have total purchases, which totaled to be 1,800,000. Also we have shelves account, which equals to 1,100,000. Also we have total sales, which equals to 2,300,000. And also rent account, which totaled to be 300,000. Next, we finalize our trial balance by finding the summation on our debit side and also on our credit side. Remember, the summation of these two numbers must be equal. So summing the values here, the total is going to be 4,366,000, and this is going to be the same on a credit side, which is 4,366,000, and this is our trial balance. Question number 15, part A, Roman 1. Determine a matrix M which represents a reflection in the line y minus x equals to 0. Okay, so this is the transformation problem. Let us consider the transformation matrix for the reflection. So we have M equals to matrix cos 2 alpha, sin alpha, sin 2 alpha minus cos 2 alpha, where alpha is the angle that line of reflection makes with the x-axis. Okay, so for the line y minus x equals to 0, alpha is going to be 45 degrees. then the matrix M will be M equals to cos 2 times 45 sin 2 times 45 sin 2 times 45 and negative cos 2 times 45, of which we are going to have matrix cos 90 sin 90 sin 90 negative cos 90. But we know that sin 90 equals to 1 and cos 90 equals to 0. Therefore, M equals to matrix 0, 1, 1, and 0. And this is the matrix required. For Roman 2, find the image of the line x plus 2y minus 4 equals to 0 after reflection in the line y minus x equals to 0. Okay, so to find the image of a line, let us find sample points from the line so that we can find their image. So we've been given x plus 2y minus 4 equals to 0. Okay, so when x equals to 0, y is going to be 2, and the point is 0, 2. And when y equals to 0, x is going to be 4. The point is 4, 0. Okay, let us now consider the relation for the transformation, which says image equals to transformation matrix times point. Symbolically, we can write as x image, y image equals to matrix 0, 1, 1, 0 times matrix x, y. Okay, so let us start with point 0, 2. So x image, y image is going to be matrix 0, 1, 1, 0 times matrix 0, 2, which will be matrix 0 times 0 plus 1 times 2, 1 times 0 plus 0 times 2. After solving this, we get matrix 2, 0. Our next point is point 4, 0. So x image, y image is going to be matrix 0, 1, 1, 0 times matrix 4, 0. Expanding this, we are going to have matrix 0 times 4 plus 1 times 0, 1 times 4 plus 0 times 0. After solving this, we are going to have matrix 0, 4. Okay, so now we have two images, 2, 0 and 0, 4. We can use them to form the equation of a line which is an image for the original line. So let us find the slope first. Recall the formula for slope, which says slope equals to change in y over change in x. So using the values which we have, we are going to have 4 minus 0 over 0 minus 2, of which solving this we are going to have negative 2. Okay, so let us recall the general formula, which says y equals to m times, in brackets, x minus x1 plus y1. Let us now substitute m with negative 2, x1 with 2, and y2 with 0. Our equation is going to be y equals to negative 2 times, in brackets, x minus 2 plus 0. Let us now open the brackets. We are going to have y equals to negative 2x plus 4. Let us now rearrange this equation. We are going to have 2x plus y minus 4 equals to 0. And this is an image of the line required. Part B, Roman 1, if A equals to that matrix, find A determinant and A inverse. So this is the matrix problem again. We are going to start with the determinant of A. We know that determinant equals to product of a main diagonal minus product of leading diagonal. So for this one, we say A determinant equals to, in brackets, 3 times negative 1 minus, in brackets, 4 times 2, of which after solving these values we are going to have negative 11, and this is our answer. Next, we are going to find the inverse of a matrix. So we know that inverse of a matrix equals to 1 over determinant times adjoint. Remember that the adjoint of a matrix is obtained by exchanging elements of main diagonal and negating the elements of the leading diagonal. So the adjoint A is going to be negative 1, negative 4, negative 2, and 3. The inverse of a matrix is going to be 1 over negative 11 times negative 1, negative 4, negative 2, and 3. Solving this, we are going to have matrix 1 over 11, 4 over 11, 2 over 11, and negative 3 over 11. And this is an inverse of matrix A. Roman 2, use the inverse matrix obtained in B Roman 1 above to solve 3x plus 2y equals to 12 and 4x minus y equals to 5. Okay, so for the given equations, let us express them in a matrix format. So we are going to have matrix 3, 4, 2, negative 1 times matrix x, y equals to matrix 12, 5. Okay, so let A equals to matrix 3, 4, 2, negative 1. Multiply calculated inverse of a matrix A on both sides. We are going to have negative 1 over 11 times matrix negative 1, negative 4, negative 2, 3 times matrix 3, 4, 2, negative 1 times matrix x, y equals to negative 1 over 11 times matrix negative 1, negative 4, negative 2, 3 times matrix 12, 5. We know that the product of a matrix and its inverse gives an identity matrix. We can write this as negative 1 over 11 times matrix negative 1, negative 4, negative 2, 3 times matrix 3, 4, 2, negative 1 equals to matrix 1, 0, 0, 1. Then we are going to have matrix 1, 0, 0, 1 times matrix x, y equals to negative 1 over 11 times matrix negative 1, negative 4, negative 2, 3 times matrix 12, 5. Also, we know that the product of identity matrix and a matrix gives a matrix itself. We can show this as matrix 1, 0, 0, 1 times matrix x, y equals to matrix x, y. Now, using this relation, we can have x, y equals to negative 1 over 11 times matrix negative 1, negative 4, negative 2, 3 times matrix 12, 5. Let us now apply the multiplication of a matrix for our right hand side. We are going to have matrix x, y equals to negative 1 over 11 times matrix negative 1 times 12 plus negative 2 times 5, negative 4 times 12 plus 3 times 5. Solving this, we are going to have matrix x, y equals to negative 1 over 11 times matrix negative 22, negative 33. Let us now apply scalar multiplication of a matrix. We are going to have matrix x, y equals to 2, 3. From here, we can conclude that x equals to 2 and y equals to 3. And this is our answer. Question number 16, part A. A bag contains 6 white balls and 3 yellow balls. A ball is selected at random and not replaced. Another ball is then selected. Find the probability of selecting 1 white ball and 1 yellow ball. Okay, so this is the probability problem. We know that probability of an event equals to number of events over number of sample space. Okay, so to solve this problem, we are going to draw the tree diagram and we are going to label it according to the probability formula. Our sketch is going to be like this. Now, probability of 1 white ball and 1 yellow ball is given by probability of the first white and second yellow, or probability of a first yellow and a second white. Remember that in probability, and used as a product or is used as an addition. So probability of white and yellow equals to PW1 times PY2 plus PY1 times PW2. So from the tree diagram, probability of white and yellow equals to 6 over 9 times 3 over 8 plus 3 over 9 times 6 over 8, of which after solving these values, we are going to have 1 over 2, and this is the probability required. Part B, we have been given several functions of x there. Roman 1, we are supposed to sketch the graph for function of x. Okay, so this is the step function problem, and to solve the problem, we are going to draw the functions one after another in order to accomplish the function of x. So we are going to draw the axis and we are going to label them. And then we are going to start with function of x equals to -4 with the values of x such that x is less than -1. We are going to draw the unshaded cycle at the starting point because the sign which have been used is less than, meaning the first element is not going to be included. Okay, so next we are going to draw the function of x equals to x squared plus 1 with values of x such that -1 is less or equal to x is less or equal to 2. Okay, so let us get the point for drawing the line using the table below. So we are going to sketch our table, and then we are going to have values for x and y here. So we have values for x as -1, 0, 1, and 2. And then for y values, we say when x equals to -1, the value of y for here is going to be 2. And here is going to be 1, here is 2, and here is 5. We also need to know the turning point of our function. So when x equals to 0, y is going to be 1. Then our turning point is 0, 1. Then next, we are going to draw the shaded cycle at the starting point and at the end point due to the use of less or equal sign, meaning the initial points are also included. Next, we are going to draw the function of x equals to 5 with the values of x such that x is greater or equal to 2. So we start with shaded cycle due to the use of greater or equal sign. The final output of our sketch is going to be like this. For Roman 2, we are supposed to state the domain and range of function of x. Okay, so observing from the figure above, domain equals to all real numbers and range equals to -4, 1 less or equal to y less or equal to 5. For Roman 3, is function of x a one-to-one function? Give the reasons. For this one, we say that function of x is not a one-to-one function because one value in a function has many corresponding values.